look at what we'll be doing today. So the first thing we're going to talk about and review is a vertical translation. Okay, so whenever we did vertical translations for absolute value bars, we were looking at this happening, and the formula for any function, not just absolute value, is that you add a number over here on the end. Okay, so that C just represents any number. Okay, it is going to shift a function up or down that many units, and it goes in the direction you think it should. So if you put a plus 7 over there on the end, it's going to move it up 7. If you put a minus 4, it's going to move it down 4. So just to give you an example of what this looks like for an exponential, let's say we have y equals, it could be any base. I'm going to use an e to the x power. If I had a plus 6 over here on the end, that would move the graph up 6 units. Okay, notice that 6 is not in the exponent, it's just a 6 over here on the end. Okay, for a log, it might look something like this. Log base could be anything. Log base 8 of x. Let's do a minus 12. Okay, what would happen to that log equation if we put a minus 12 on the end? Down 12. Okay, so it is not inside of the parentheses for your log. Sometimes you'll see this written. It'll look like this. Y equals log base 8x minus 12. If they don't put parentheses at all, then they're assuming just the next thing after it is in the parentheses. Okay. So numbers on the end move our graph up or down. Let's look at the next one. Okay. The horizontal translation is whenever we add a number on the inside of the parentheses. So we see that number on the inside of the parentheses. For absolute value, it meant it was on the inside of the bars, right? The bars were like our parentheses. For exponential and logarithmic, it's going to look a little bit different, but it's still the same rule. If we add a number in here, it's going to go left or right, b units, but it goes in the opposite direction of the sign. So if I have a plus b, a positive, it's going to go to the left, which is actually the negative direction, right? And if I have a minus b, it's going to go to the right. Okay? For an exponential, it's most of the time not going to have parentheses. What it'll look like is something like this. Y equals, the base can be any number. It really doesn't matter. Let's say it's a 3. X minus 7. Okay? There are not parentheses there, but whatever is in the exponent, that's where your parentheses are at. That's like it's got parentheses with it, right? If we type it into Desmos, we have to put the parentheses there, right? It doesn't keep that minus 7 up there unless we put the parentheses. So that minus 7 right there, what would it do to this graph? It would go to the right 7. I'll put that right there, right 7 for this one. So opposite sign. The negative actually makes it go to the right. Okay, questions so far? All right, an example for a log might look something like this. Natural log of x plus 2. And it will be in parentheses, and you have to have the parentheses written there. What would this do if I had a plus 2, William? It would be left 2 for this one. Okay. Questions? All right. the trickiest one that we looked at was the vertical dilation. It's really the trickiest one to figure out if you are looking at the graph. Sometimes it's hard to tell, especially with logs and exponentials. But vertical dilation is whenever we multiply by a number out front. And if that number, I messed these notes up. That right there should say A is greater than 1, not A is greater than 0. So fix that on the notes. Okay, A should be greater than 1 right there instead of 0. I messed that up. So if you have a number bigger than 1, it is going to stretch that graph out. It is going to make all of your y coordinates taller, and it's going to make it look taller and skinnier. If the number is between 0 and 1, it is going to squish it down and make it shorter and fatter. I will tell you, these are really hard to tell from the graph with exponentials, so I'll give you a hint of how we can look at that, because we'll be able to use Desmos for everything whenever we get to some examples. So exponential example would look like this. You might have something like y equals 4 times 2 to the x power. Okay, so this part right here, the 2 to the x power, that's your exponential. The 4 is what's stretching that out. That would make it taller and skinnier. It would stretch it this way. An example of a logarithmic example would look like this. Y equals 0.2 log base 5 of x. And so that 0.2 right there, that's the number that's being multiplied by your log equation. It's going to, in this case, shrink it down. It's going to make it shorter and fatter. Okay? Okay, questions? All right. I think there's one I forgot on here. There is. Okay, let's add this over in the corner somewhere, or is there, if there's, you can put on the back maybe of these notes. I forgot one right here. That is a reflection over the x-axis. What flips it upside down. Does anybody remember what we did to flip something upside down when we had the absolute value bars? It's a negative. So if you have negative times whatever the function is, negative f of x, that's going to flip it upside down. Okay. For an exponential, it will look like this. Y equals negative 5 to the x power. No parentheses with that negative 5. That would be crazy stuff. And then our log example would look like this. Y equals negative log base 3 of x. So you just put a negative in front of the equation and it flips it upside down. I forgot to include that one. We'll go back and add that for next year. Okay, so remember, you guys can, we're not going to get out the note cards and do it right now, but you can use a note card on your test. I would include some of this stuff on my note card to remind me about what happens. So I gave us several questions. Actually, no, these are not like what you'll see on tests, and the others are. So we have to tell the parent graph, describe each transformation for these three functions. So I think the exponentials are a little hard to tell what the parent graph would be. An exponential is something raised to the x power. Okay? So, we would have parentheses around this. I feel like some of you guys are on your computers not paying attention. So, please, I'm not going back over this. So 2 to the x plus 7 right here. Whatever is in the exponent, like down here, that has parentheses around it. That's where your parentheses are at. So the parent function for example 1, the parent would be y equals 2 to the x power. 2 is not a transformation because it's the number being raised to the power. Okay, so this part right here, the 2 to the x, that's your parent function. The only other thing you have here is this plus 7. So you've just got one transformation happening here. If we put a plus 7 on the end, Jason, what would that do to my graph if I put a plus 7? Nope. On the outside, if it was in the parentheses up here, it would move it left. Okay? Out here by itself, not in the parentheses, it's going to be up 7. So it's been moved up 7. Okay? And let me show you guys on Desmos, because if you get something like this, you can use Desmos on everything. We love Desmos. Makes our lives easier. If you go over here, type in y equals 2 to the x. There's the original. Type in y equals the 2 to the x plus 7. You can kind of see, oh yeah, that looked like it moved up, not left or right. So you can double check yourself on these. Okay? Let's do this. Let's slide this over. Leave that's myself there. All right. So the next one, okay, I think it's a little easier to tell parent graph with logs. Your parent graph for this one is just y equals log of x. Okay, so right there's the parent graph. This minus 3 right here is what's causing there to be a transformation. Okay. So, Carlos, if I have a minus 3 on the inside of those parentheses, what does that do to the graph? Correct. It's going to go right 3. And if we graph it, if we go over here and graph this, the parent would be y equals log x. If I graph y equals log x minus 3, you can kind of see, oh yeah, that shifted to the right. Sometimes it looks a little up or down. Maybe that kind of looks a little bit like it's down. But think about where that vertical asymptote is. That's definitely been shifted over there. That's going to be to the right. Okay. Can anybody tell me the parent function for that last one? Okay. I'm hearing up 5, right 4. Those are the transformations. What is the parent? Parent function is y equals e to the x power. Right? So it's just that e is not a transformation. It is the parent function. But the exponent would have parentheses around it. The 5 over here does not. So Alvin is exactly right. That 5 right there is going to make it go up 5. And then the minus 4 is going to make it go right 4. These are a little hard to tell from the graph. That's why it's important to know the rules also. So if I graph y equals e to the x, and I graph y equals e to the x minus 4 plus 5, it's a little hard to tell exactly. You can tell that this went up and to the right because that graph is certainly up. For up and down, think about where that horizontal asymptote moved. It moved up 5. You can see that how far it goes right is a little bit tough. You could pick like that point right there, and if you go up 1, 2, 3, 4, 5, and to the right 1, 2, 3, 4, it gets you right there, which looks like it's kind of the same position on the graph, so that can help you, but it's a little bit tough. Usually, though, these are going to be multiple choice, so you can kind of rule out things, and if you know the rules, you can do it without even looking at the graph. And you can use a note card. So I'd have those rules on that note card. Okay? Alright, we okay here? Alrighty. Let's look at what some of these questions will look like. Okay. Which graph shows natural log of x plus 2 minus 3? Let's try to do it without the, well, first of all, over here I'm going to graph the parent, y equals ln of x. Now, I know you could probably do this with Desmos even if you knew nothing. And that's how it is. But what happens to this graph, Alex? What is going to happen? Got it backwards. The number on the outside, that's the one that goes up or down. This number is the one that moves left or right. So the minus 3 will make it go down 3, and the plus 2 left 2. So you did the inside up and down, outside left and right. So outside is your up or down, inside is your left or right, and it goes in the opposite direction. So which one of these looks like it has been moved down 3 and to the left 2? I think it's C. Now, you know, I'm giving you Desmos, so don't rely completely on your knowledge. Type it in, okay? And then let's get rid of that one. So, yeah, that definitely looks like C's the answer, right? If you're not sure, find exact points on that graph. Like I can see right there, that graph looks like it goes through -1, -3. This graph goes through -1, -3. These other graphs don't go through -1, -3. So I can see that's my answer. We okay here? Not too bad, especially with Desmos. All right. Okay, try that one on your own. Desmos won't let you type f of x in 3 times, so you might just want to use a y equals instead, or call it g of x and h of x. Okay, which one do you guys think? A? Okay. A, right here, and freeze, has been moved. How's it been moved? That plus 3 makes it go left 3, and that minus 2 makes it go down 2. I can definitely see it looks like it has a horizontal asymptote at -2, so that's good. C also does, so it's an option. B would be out. If I look at the graphs one at a time over here, option A definitely looks like the best choice. Check exact points. I can see like over here, that goes through the point, or pretty close to the point 1, 7. So I should have 1, 7 on this graph. Yeah, it goes to that point. So check points to see. You can see like here, my x-intercept is right there at -2.369. That looks like about the same place over here. So check points to make sure it's exactly right. We good here? All right, next one. Okay, we want to know the one that's been translated to the right 4. Okay, Carlos was it Carlos that said C? All right, do you guys agree? Okay, because it's going to be what's on the inside, but it goes the opposite direction. So C is the correct answer for example 6, right there. Okay, you can check that, but I feel pretty good about that one. All right, now these are the ones kids always miss. So I want you to type these in and pick one for me there. Type these in and pick one. Type those in on example 7 there. Just type L in. You just type the letters L in. Yeah, I don't know if there is a button for natural log, but just type L in. It'll grab it. All right, which one do you guys think? B? You guys are correct. B is correct. Whenever you look at them one at a time over here, yeah, if you just look at natural log, it doesn't look terrible, but you can see like that crosses, oh, that crosses at 1, 0. That one crosses at 1, 0. That looks pretty good. Check another point though. This crosses about 3, 1. 3, 1 right here. Oh, that does not go through that point, right? So, so check some exact points to see if they match up, because sometimes they will look pretty close. Like if they had given you an option of 3 natural log of x, do you think you guys would be able to tell the difference between 3 natural log of x and 4 natural log of x? You're pretty good if you can. But I could see, oh, that blue line right there goes through about 5, 5. That one does not go through 5, 5, right? So it would have to be the green line would be a better answer. So check exact points. See if those points match up exactly for that. Does that make sense when I say check exact points? Yeah, so like whenever you graph it, you're looking to see oh, this line right here, it goes through about that point right there, which is 5, 5. But if I go to that same point over here, 5, 5 over here, that doesn't match. So whatever my blue graph, which is, I put 3 natural log of x, which wasn't an option here, that couldn't be the answer. So then you would look, well, maybe, oh, that one looks like 5, like, you know, maybe 5, 6 and a half, 5, 6 and a half. Oh, yeah, that hits the same point. So that'll help you match up with those. Alrighty. Okay, try this one. I want to see if you guys can get it right. Most of the time, students don't get these right. This is the hardest right here. What do you guys think? All right. What? How did you get A, Ayla? So it's important to know which one's F and which one's G. So F is this black graph right here. That's what you're starting with. And so it's becoming the red graph. So if I'm going from the black graph to the red graph, am I going up or down, first of all? I'm going up. So that means that I'm going to not use A or D. Because F is the black graph. I'm shifting it to make the G graph, so it's got to go up. And if you look just at the equations, you might want to say it goes up 3. Because that red graph, it is an equation, if we take the parent graph, 2 to the x, it's been moved up 3. But we didn't start with the parent graph, right? We started with this black graph right here. So that black graph, if we look how far it's been moved up 8. So C would be your answer for that. And if you think about what's happened there, you started off with one that was down 5, right? That is a graph that had been moved down 5. And then you went to one that was up 3. This part right here stayed the same. So one that was down 5 to one that was up 3, that's a difference of 8. Right there. You okay there? All right. This is our last one. Okay. All right. This equation is transformed to produce this graph. What happened to it? So here is what we start with. We start with, I'll graph that for you, f of x equals log of x minus 2. So we start off with this graph right here. We end up with this graph. And you know what happened to f of x? Okay, I got a few people up here telling me D. Do you guys agree? Okay. Now, that looks like it has been moved over 4 to me. It looks 4. But, Passion, where did we start? This was our original. Where did it start at? It started, that vertical asymptote right there started over here at 2. So, since it started over here, like the original was over here at 2, well, if I can draw, I don't know, oh gosh, it changed it to letters. I didn't even know I could do that. Okay, there we go. We started over here at 2. Oops, that's drawn terribly, but right there at 2. So if we had started at the x-axis, if it was just the log of x equation, it would be left 4. But we started at 2, so it had to go left 6. So D would be the correct answer for that. Okay. I had a worksheet, but we'll just save that for Monday. So that is all we have for today. You guys, I probably am going to move that to Tuesday instead. No, I'm not. Oh, gosh. I have to think about that quiz because so many of you are going to be on that Surrey trip. We're definitely still doing stuff, but I don't really want to give a quiz on a day 10 people are going to be out. So we may or may not quiz this section. I'll have to decide.